Hi, my name is Richard, and I'm a data science evangelist here at Coiled. In this video, I'll be showing you how to scale your data science workflow using Dask and Coiled. We'll start by looking at a conventional Pandas workflow. From there, I'll show you how to scale that workflow up using local parallel computing with Dask. Finally, I'll show you how to scale that same workflow out to leverage the power of cloud computing using Coiled. You can follow along in the notebook at this link. All right, let's get started. Let's start by taking a look at this basic Pandas workflow. We'll download the New York City taxi dataset from the public S3 bucket using the wget command. This will download the entire dataset to our current directory. We'll then import one of the 12 CSV files into a Pandas data frame using pd.read_csv and perform a common analytics operation, grouping by the passenger count and getting the mean tip amount using the group by and mean methods. All pretty straightforward, right? But note that we only imported one of the 12 CSV files. What if you were interested in calculating a result for the entire dataset, which you usually would be? Working with Pandas, you would run into a problem here because the entire dataset does not fit into our machine's RAM. We could write a for loop like this one, or maybe read the data in chunks, but it's a little convoluted and not ideal. And why opt for less than ideal when there's a perfectly great alternative? This is where Dask comes in. Dask is an open source Python library that lets you take advantage of all of the cores in your laptop in parallel. This is what we call scaling up your computation. Dask is just one way of doing parallel computing. But the great thing about Dask is that it was built with ease of use in mind. Its API was built to be as close as possible to the PyData API we all know and love, in this case Pandas. So let's take that same workflow above and scale it up to process on multiple cores on our laptop in parallel. We'll import the necessary Dask components, spin up a cluster, and instantiate a client. There's a lot more to say about how Dask works and all of its magic-like components that we can't squeeze into this video. For more information, do check out their docs and tutorials at dask.org. We'll go ahead and import the data, all of it this time, into a Dask data frame. As you can see, the Dask API is very similar to the Pandas API we used above. We use dd.read_csv and simply add an asterisk to the end of the file name to tell Dask to download all of the CSV files in one go. We'll then prepare the same group by and mean computation, again using very similar API. Note that Dask doesn't actually calculate the result of this computation until you explicitly call compute. This triggers the computation, and we can then follow along in this interactive dashboard to see how our computation is progressing. Fantastic! We managed to calculate our result over the entire dataset. An operation that wasn't possible in straight-up Pandas now took less than 10 minutes to complete. But what if you're really in a rush? Or maybe you have even more data to process? Are you always going to be limited by the memory capacity of your machine? The answer is no, of course not. You can scale out your workflow by leveraging the power of cloud computing. Using Coiled, you can spin up a Dask cluster in the cloud and access vastly larger amounts of processing power than are available on your machine. Coiled connects to all of the three major cloud providers: AWS, Google Cloud Platform, and Azure. We'll go ahead and start by setting up Coiled by first signing into the Coiled free tier, preferably using your GitHub credentials, then pip or conda installing Coiled, and finally authenticating using the token at cloud.coiled. Now that we're all set up, we can go ahead and import Coiled, as well as the Dask components we used before. We can then spin up a Coiled cluster in 4 steps. First, we create a software environment that will make sure your workers have all of the dependencies they need to run your computation. Secondly, we'll configure the cluster specs, like worker and scheduler memory. Third, we'll spin up the cluster with the specified number of workers, in this case 20. Finally, we'll connect Dask to the remote cluster. This again gives us a Dask dashboard, which we can use to track progress and diagnose any issues on the cluster. We can then use the exact same Dask API we used before, except this time the computations won't be done by your local machine, but will be sent to the cluster in the cloud, where it will execute much faster. So we'll go ahead and set up the computation and call compute and just wait for that to complete in less than 20 seconds. That's a massive speed up compared to the local Dask computation we performed earlier. This is the undeniable power of cloud computing right here. All right, let's recap. We started out with a conventional workflow in Pandas. It was pretty straightforward, but we ran into the problem that our dataset was too large for our machine's RAM. We solved this problem by processing the entire dataset locally using Dask. Finally, we optimized that solution by running Dask on a cluster in the cloud, achieving a massive speedup of over 20 times. All right, that's it. We hope this video helps you achieve the impact you're striving for in your data science workflows. If you have any questions or suggestions for future material, please do get in touch via our community Slack or support@coiled.io. Thanks for watching.